Okay, so we're going to do a quick review of, hang on, let me get this open. There we go, of the difference between linear functions and exponential functions. So if I'm taking a look at this, right, we're going to talk about what the linear function looks like and what the exponential one does. You guys remember that a linear function takes the form y equals mx plus b in the slope-intercept form. And the m represents the slope, which is why it's called the slope-intercept form, right? But we also sometimes talk about that slope as a rate of change. Okay, so we're going to compare that in a second to our exponentials. And the b is the y-intercept. But again, that was also sometimes thought about as the initial value. Okay, so when we talked about, starting from a certain amount of money and then increasing in an account a certain, added $50 every week to the account to get the savings, that was the number we started from, right? So if we're looking at an example here, right, and we have the example 3x plus 2, we can do one of two things, right? We can plug in each of our numbers. So let's say we start with -2, we do -1, 0, 1, 2, right? This is going to be 3 times -2, right? The x becomes our number, our input number, and we get our answer. Well, 3 times -2 is -6, plus 2 is -4, right? From there, you can either keep entering, each number, or you can think about what the slope is of this equation, right? The slope is 3, so each time I'm going to be adding 3, so -4 plus 3 is going to be -1, right? Plus 3 is going to be +2, right? Plus 3 is going to be +5, and then plus 3 is going to be +8. Again, if you went through and just calculated all of those, right, you get the same answers, right? 3 times -1 is -3, plus 2 is -1, okay? So we can go through and just 3 times 0 is 0, plus 2 is 2, right? We can enter each of our input values and get our answer, or we can use the slope to complete our table this way, okay? As you prefer, okay? So as we're going to compare in a second, right? We'll draw our graphs in a second, but let's look at just the equations and the tables first. So we know that from our first day of lessons that the equation of a exponential function takes the form y equals a parentheses b to the x power. So our a in this case, unfortunately, I wish it was the same, the b part, I wish they named this letter b because then it would be the same as the y-intercept, right? This is now our y-intercept, or our start, right? Our starting value. Just like here, it was our initial value, right? What are we starting with? What is the number of something that we're starting with? And then B is going to be our multiplier, right? Or our factor of change, right? A factor just means something we multiply by. So I called it a bunch of times a multiplier, so I want you guys to know that too. But sometimes you might hear it called a factor of change. Now over here we had a rate of change, right? Over here we have a factor of change, right? They're the same sort of thing, except for here I'm multiplying and here I'm adding, okay? The same number each time. So when we go through this, let's think about what's going to happen, right? -2, -1, 0, 1, 2. And we're going to have 2 times 3 to the -2nd power. And some of you might struggle a little bit with figuring out what 3 to the -2nd power is. And so I'm going to let you guys, if you want to, use your calculators to figure out these values, okay? A negative exponent is like we're dividing by that exponent. We talked about that a little bit, but let me turn on my calculator, and you guys can also use your table of values, right, to do 2 parentheses 3 and then to the -2nd power. Okay, oh, actually, sorry, I want to put in the x in there, right, because I want to get all my values at once. If I put the -2 in there, I would just get that one value. I want to put the x in so I get all my values together. So then I look at -2, and I get 0.222, right? Remember, this means I'm dividing something, right? I've got 0.22. Okay, we can just round it. And then this one's 0.66. And this one is 2. And this one is 6. And this one is 18. Okay, so now let's think about what we're talking about here. And it's a little easier to see if you look at the top here, right? We did 2 to the third power, or 2 times 3 to the negative first power, and 2 times 0 to the 0 power. Sorry, 2 times 3, my brain is off. 2 times 3, right? This part doesn't change, only the exponent is changing. And then 2 times 3 to the 1, or to the first power, and then 2 times 3 to the second power, right? So all of these are what I would do if I did it by hand, but your calculator can do them for you too. But what's actually happening over here? We have 0.22, and we are saying that our factor of change is multiplied by 3. Well, we're multiplying by 3. When you multiply 0.22 by 3, you get 0.66. When you do the same thing and you multiply 0.66 by 3, you get 2. When you do 2 times 3, right, we get 6. And then again, you'll see here, if we do 6 times 3, we get 18. So notice the multiplier here is something that we multiply by, right? That's the factor of change. And the slope or the the slope or the rate of change is something that we add to each value each time. Okay, so we're increasing by the same number here, and here we're multiplying by the same number each time. And so again, we've looked at graphs of this. So let's take a second and just draw an axis here, okay? I'm going to draw it a little bit lower so that we can get most of our numbers on there. Draw the x-axis down here. And then we know that our y-intercept, right? Our y-intercept in a linear equation is that number 2, or it's the number across from 0 on our table, right? So 2, 0, 2. Okay, and then each time, right, I'm going up 3 and over 1, right? That's our slope. And if you can't remember how to do the slope, just look at your points on your table. Your next point is 1, 5. Well, here's 1, 5, right? And then your next point is 2, 8. 2 and then 8. So you're going up another 3. Okay, and if you go back to the previous point, it's negative 1, negative 1, right? Negative 1, negative 1. So we can create a linear graph here, right? A graph of a line based on this information. Well, let's look at what we have here. I'm going to draw my graph sort of in the same place. Okay. I'm going to draw it sort of lower on your, draw your x-axis lower so we can fit more numbers up here. And we're going to start with negative 2 and 0.22. Well, negative 2 and 0.22 is going to be really close to 0. And then negative 1 and 0.66 is going to be a little bit higher. Okay. And then 0 and 2 is going to be here. And 1, 6 is going to be 1, 2, 3, 4, 5, 6. Okay. And then 2, you're going to notice already 218 is not going to fit, right? It will be way up here because as exponential equations do, they go up really fast, right? They start slow or they start low, but they go up really, really fast. And so even though we have the same y-intercept, right, the same starting value, this one's going to go up kind of in the same rate, and this one's going to go up much faster as it starts to increase. So the difference of these two types of equations, right? I'm adding 3, here I'm multiplying by 3. All right, last thing, the domain and range, okay? When you're talking about a linear equation, right, my domain, if I think about this arrow is going up in this direction forever, and it's going wider in this direction forever, right? It's going to keep getting wider, it's going to keep getting taller, it's going to keep going. So my domain is going to be all real numbers. You can write this like this, IRN, or you can write all real numbers. Okay, so either one of those works because my domain is my x values, right? I'm going to keep going. As my line goes this way, it's going to keep getting wider and wider too. And as it keeps going up and down, as you see the arrows going, that's my range, right? So any number, right, could be part of my range. It's basically negative infinity to positive infinity, okay? That's another way you might see this written sometimes, negative infinity, right, to positive infinity, all right? So those two, right, could be the way that that's written, okay? But also just writing all real numbers works as well. All right, with an exponential function, remember we talked about the asymptote, that line that it never touches? Well, that's kind of my boundary on the bottom. So we talk about domain. Domain, the x's are going to keep going forever because this goes in this direction forever, and this does get wider and wider and wider and wider up here, and it's going to keep going this way. So my domain is still going to be all real numbers because my x's, remember my domain is my x values, or my left to right of my graph, right? There is no boundary. It's going to keep going. But the boundary for the range or the y values does have a limit, right? It does not go past 0, right? It doesn't even touch 0. And so this boundary, the asymptote, is important when you talk about the range of an equation, right? Because there's an invisible line here which it will not cross. That's called the asymptote. It's also your bottom of your equation. So all of my numbers have to be greater than 0, right? So my range is where y is greater than 0, okay? You could also write all positive real numbers, okay? That would work too. But usually you'll see it written like this, right? So y is greater than 0, or you will see something that says, right, 0 to positive infinity, okay? Because it starts at 0, that's my low end, right? And positive infinity is my high end, right? I can go forever upward, but I don't go down, right? This graph is not going down. In some examples, we'll look at some that are flipped over and they're going down later, okay? And they have a different, right? They would go from 0 to negative infinity, okay? Or they would be y is less than 0. But in these cases, it's all the numbers greater than 0. So as you go through your activity today, you're going to be asked to identify these features of the graph, right? The y-intercept. We're talking only about exponentials now. I just want you to see how they compare to each other. But we're going to have to find the y-intercept. You're going to have to find the multiplier. You're going to have to find the asymptote, okay? And some of those features for a bunch of different graphs or equations. And so the link for that is on ClassKick. So when you finish watching this really quick refresher video, you should be able to access that. And if you have any questions, I'm there to help. So let me know.